this video I'm going to be talking about some of the ways that we assess economic values in microeconomics, including totals, averages, and marginals. And we'll be encountering variables that will take this form really throughout the rest of the semester. The idea, totals are pretty self-explanatory. It's simply the collection, the aggregation of any kind of data. If I take everyone in the class, add up their age, I get a total age or an aggregate age. It may not mean very much, but it would at least give us a total. Averages are what we think they are. If I took everyone's age in the class and divided it by the number of people, I could have an average age, and maybe that might be particularly useful in that particular example. But really where the most usefulness of doing economic analysis comes from is in marginals. And marginals are simply the measurement of incremental changes in some variables as we progress from one level to the next. So very rarely do we have situations in which the values under consideration are 0 or infinity, as problematic as a value as infinity is. So it's really as we go from one level to the next level to the next level, what is the change in some underlying value? And again, with totals, averages, and marginals, we can apply these in terms of units, whether it's hours worked, units sold, units produced, or in terms of dollar figures. And so we'll be looking at this in both directions through the next few videos as we sort of build up to the economics of the business firm. But before we do that, I want to talk a bit about the economics of households, in particular the concept known as utility. Utility is simply defined, and your text has a good definition, as the usefulness or the satisfaction or the benefit of consuming some good. And if goods didn't give us utility, no one would consume goods. And we measure that utility in terms of total utility with the hypothetical unit of value called utils. And right now we don't really need to worry about what a util is. It's hypothetical. One thing that we do know is that some goods give more utility than others. It's probably safe to say that a trip to Disney World has more utility than a trip to the city park. Again, everyone's different, but I think most people would decide that there's more utility in that. And here's the thing with utility. If we plot total utility against quantity consumed, and again, we're talking not about production, but about consumption, the economics of the household, or the economics of the consumer, we'll notice that as consumers demand and consume more of an item, that total utility begins to rise. And this is an important concept. And it isn't just, I know some of the examples that are often used for utility sort of links this back to an individual. As an individual, I consume units of some good, whatever it is, glasses of tea or cups of coffee, whatever. But it's really for the entire market and how much utility or benefit consumers get from that. And notice over time that there's sort of a tailing off. And so the total utility function sort of does this. It rises from 0 and it picks up steam over time, but then sort of reaches a point at which there's 0 new utility. In fact, utility now becomes negative. And that's simply a function of scarcity or the lack thereof, or saturation, seen enough of this particular good, had enough, the entire demand side's had enough. There are some goods like water, for instance, that have very tiny amounts of utility per unit as we consume them. So what about this as we go from here to here, here to here, here to here, along the quantity axis? Well, if it eventually goes to a 0 slope and then becomes negative, then one thing we know is this, that we can measure the incremental change in this by taking the value called marginal utility. Again, marginals are those values that measure changes in values at some incremental level. And so it's measuring the change in total utility divided by the change in the quantity. And where have we seen this before? We've seen this with slopes of functions. That is, the change in this y value divided by the change in the x value. That looks like rise over run, and that is slope, and that's exactly what this is. And notice that marginal utility actually goes down as we measure from one incremental level to the next. Even though it's still rising and it's still positive, it's positive over here, it's positive over here, it's still a diminishing function. And so one thing that we can say about marginal utility is the first of a number of functions that we're going to be encountering in the course that we call diminishing functions. That is, over time, the value goes down. And as to the change in total utility divided by the change in quantity, it's simply like the change in anything. These delta symbols, these Greek symbols simply represent new minus old, new minus old. And it could be anywhere. It could be from 6 to 7, and so we have total utility 7 minus total utility 6 over quantity 7 minus quantity 6. So you get the idea, and as a result of this, this value is going to be going down. And oftentimes it's more of a curve than it is a linear function. But notice a couple of things here. Notice as we flatten out, go to 0, we've actually got marginal utility of 0. That is, there is no change. In fact, because the slope is 0, so is the value of marginal utility. And once this becomes negative, the slope is negative, then it's an actual negative value here. It is possible for the demand side to consume enough goods in which there's negative utility being earned. And just think about any good in which there's simply too much consumption, and as a result, there are negative consequences. And so this is a demand side concept, and it applies really across the demand side. But here's a more important concept relating to utility, and in particular marginal utility. What is the way that we can bring it back to the market that we've talked about before, particularly the market for demand and supply, and that's to bring in dollar figures. And so what's more important than marginal utility is the idea of marginal utility per dollar. Marginal utility per dollar. And as a result of this, we're saying for every dollar that I spend on this next unit of consumption, this is the amount of marginal utility that I get. And when we talk about marginal utility per dollar, well, we're talking about goods that trade in the marketplace, and so it's simply the dollar value of that good is expressed in terms of price. And so as a result of this, we can say that for all goods across a consumption bundle, and a consumption bundle is simply defined as the collection of goods that an ordinary household will buy, and because households are different, they have different consumption bundles, and as a result of this, we would expect different combinations of goods. But we can simply say this, we can simply say that for every good in a consumption bundle, that the marginal utility to price relationship should be equivalent. So the marginal utility of good A divided by the price of good A should equal, even though the prices are different, the reason the prices are different, the theory goes, is because the marginal utilities are different, should equal the marginal utility of good B all the way up to the marginal utility of good N divided by the price of good N, where N is the number of goods in the bundle. Number of goods in the bundle. And so we recognize, and we all know, that goods have different prices, but one of the reasons they have different prices is because they yield different amounts of utility. A Cadillac car is probably going to give more marginal utility than a Hyundai, and so as a result the Cadillac has a higher price. And so this is really the theory of optimal consumption bundle. And to sort of illustrate how this works, let's take an example here of two goods, and we'll simply refer to them as good X and good Y. And we'll illustrate the substitution effect, which we've previously described as being one of the determinants of demand, that is the price and availability of substitutes, one of the demand determinants that can cause a shift in demand. And so let's start with a number of conditions here, and let's start with an initial base condition, and we'll simply refer to this as condition A, in which we've got a similar situation with regard to the setup of two goods and having equivalent consumption bundles. And let's say that for good X, the marginal utility of good X divided by the price of good X is equivalent in the quotient to the marginal utility of good Y to the price of good Y, which just happens to be two different priced goods. Good X goes for a price of 3, while good Y goes for a price of 4. Different prices, different goods, but we're going to illustrate how and why there's a substitution effect. And let's just assume that at the particular level of consumption, that the marginal utility at that particular level, whatever it is, and we don't know what it is, it doesn't really matter, gives us 6 units of marginal utility, whereas for Y it gives us 8 units. And so as a result, what do we have? We have the marginal utility of good X, the marginal utility to price of good X being equal to the marginal utility to price ratio of good Y as being equivalent. Two different kind of goods, two different prices altogether. And as a result of this, we can see that there's no issue here with regard to the inequality, because they're inequality. Now let's say, under condition B here, that a change occurs in the price of good Y. Okay? A change occurs in the price of good Y. And we're going to say here that the price of good Y, let's say it started at 4 here, and now it goes to P2, which is 2. So now the price has fallen, and we don't particularly care what the precise reason is. It could be an influx of imports that have driven down the price for all goods in this market. Could be cheaper production processes, lower labor costs, lower materials costs, more competition, all of those things which might cause maybe a shift in supply, which we're not really concerned about, but we are concerned about the effect of a reduction in price. And so as a result, what have we got going on here? Well, we've got this kind of thing. If we reestablish the marginal utility to price relationship for both goods, good X and good Y, what do we have here? Marginal utility to price for good X, marginal utility to price for good Y. We're going to be in an out of equilibrium condition because we're assuming that just initially at least there's no change in the amount of consumption of good X, and we have that kind of ratio. Whereas with good Y, we have a lower price, but the same amount of initial utility, marginal utility, and so we've got an inequality going on. So we're going to see a shift in demand for good X, and that's what I'll model here in just a second. And the reason why is because what's one of the determinants of demand? It's the price and availability of substitutes. And so what will happen here is that less quantity of good X will be consumed. Less quantity of good X will be purchased, and the reason is very simple. This gives a higher ratio, the same good. In fact, this was a good that used to have a higher price than good X, and now it's actually got a lower price, so it's definitely going to be more attractive. So there'll be less quantity of X purchased as a result of this particular thing. And actually the reason that there's less quantity of X at every price is because there's a leftward shift in the demand curve. So there's a leftward shift in demand for good X. Leftward shift in demand for good X. Whereas with the price of good Y now changing, then there's going to be a sliding along the demand for good Y, and so more quantity of good Y will be demanded. More quantity. Okay? So as a result of this, we're going to attempt to show then how we reestablish the equilibrium at this particular point. And if you need to pause and get a copy of that, that's fine. What I'm simply going to do, though, is to simply show how this is modeled and how the substitution effect actually works in everyday life with regard to two goods that actually have substitutability one for the other. And it doesn't really matter what kind of generic goods we have. So anyway, we're talking about good X and good Y. So we've got one market here, the quantity of good X and the price of good X. And we've got another graph over here, quantity of good Y and the price of good Y. And so what do we say is going to happen in this scenario? Well, we started with some condition where we had demand for good X, and we'll call it demand for good X1. The 1 is a superscript here. And as a result of this, we started out from our initial condition at a price of 3, and in fact the price still is 3. Nothing has changed with regard to the price of good X. The changes happen with the price of good Y. And so, but what has simply happened is now this good is no longer as attractive, and so as a result, the demand curve will shift. We'll call that D2X, the 2 being a superscript, and as a result, there's a leftward shift. And what do we know about a shift in demand, in this case a leftward shift in demand? We know that if there's going to be a leftward shift at every price, there's going to be less quantity demanded, and so as a result, the quantity demanded is going to shift to the left. On the other hand, with good Y, we've got demand for good Y over here. We started out with an initial price of $4. The price has now fallen to $2. P2 is 4. And so as a result, what do we see happening here? We've actually got a rise in the quantity demanded. This is why quantity demand is changing. It's because of the fact that the price of this good has now changed. So to take this to the next step then, what we need to do in order to bring it back to marginal utility is to actually graph the marginal utility curves for both of these particular goods. And so let's do that. And I'm going to go ahead and erase this and then simply recreate these and then arrive at the final condition, which is a reestablishment of the balance in marginal utility to price, that ratio between these two goods. And so this is not the market of demand and supply as plotted against the price and quantity. This is simply the market of marginal utility in relation to the quantity of good X, and then marginal utility in relation to the price of the quantity of good Y. Okay, marginal utility. And I'll go ahead and specify marginal utility of Y, marginal utility of X. And so what about these marginal utility functions? Well, we know that marginal utility is a downward sloping curve. It's a diminishing function, so the marginal utility of X looks like that. Marginal utility of Y looking something like that. And so what do we know about good X then? We know that there's going to be less demand for good X. So as a result, we're going to buy fewer units at every price. And so we know that that quantity, if you refer back to the same quantity axis, only we plotted against price, we knew that we're going to be sliding from Q1 to Q2 because of the leftward shift in demand. So there's going to be less quantity, and we're going to say that we initially started at the original point, Q1, we had 6 units of marginal utility, and now let's say that we've got 9 units. So marginal utility is actually rising because we're consuming less of this. We're moving up the marginal utility curve simply because of the fact that we're consuming less of it. It's now more scarce in the eyes of the demand side, so we're actually sliding up along that. But we're doing just the opposite over here. We know that there's going to be more quantity consumed of this good due to the lower price. But as we do this, remember we start out with the initial condition of 8 units of marginal utility. Now we fall to some, let's say 6. And as a result of this, as we consume more of any good, we get less and less marginal utility, less and less value. And so the final condition then is this. It's simply to reestablish the marginal utility to price relationship. And so for good X and good Y, all we now need to do is to simply reestablish at these new levels after the market has adjusted for the differing levels of quantity that are demanded. The differing levels of quantity that are demanded. And so as a result, let's do the math here. So we're actually now getting 9 units of marginal utility at this reduced level of X that we're consuming because of the relatively less attractive price over the same price of $3. The price hasn't changed, nothing has changed. But here, we're actually getting less marginal utility because we're consuming more of this particular good at the new price of $2. And so as a result, 9 over 3 is 3, 6 over 2 is 3, and so we've reestablished the marginal utility to price relationship. And in a series of graphs, which I hope you'll take one at a time, we've illustrated the fact of how the substitution effect works in terms of the differing levels of marginal utility at every level of consumption of the good. So I hope this was helpful, and again, as always, feel free to contact me individually if you'd like more information.